Ramanujan for G is now available on the Google Play Store. Try it out for free.
Good morning, class. So, in the determinant lecture, we're going to start with the multiplication of two determinants. Okay, so let me write down the heading first. Wait. Multiplication of two determinants. Okay. So we're gonna solve for these second order determinant. Okay, so that is a1, p1, a2, b2 multiplied by l1, m1, l2, m2. So it becomes a1 l1 plus b1 l2, then a1 m1 plus b1 m2, then a2 l1 plus b2 l2. Here a2 m1 plus b2 m2. So this is the multiplication for the second order derivative. Now for the third order determinant. Third order determinant, meaning a1, b1, c1, a2, b2, c2, a3, b3, c3 multiply by l1, m1, n1, l2, m2, n2, then l3, m3, n3. So whole is equals to a1 l1 plus b1 l2 plus c1 l3, then a1 m1 plus b1 m2 plus c1 m3, then a1 n1 plus b1 n2 plus c1 n3, then a2 l1 plus b2 l2 plus c3 l3, then a3 l1 plus b3 l2 plus c3 l3. Here a2 m1 plus b2 m2 b2 m2 c3 m3, then a2 n1 plus b2 n2 plus of c3 n3, again a3 m1 plus b3 m2 plus c3 m3, again a3 n1 plus b3 n2 plus c3 n3. Okay, so this is the multiplication of two determinants of third order. Okay, so you copy both second order as well as the third order. It's gonna helps a lot you. So in above cases, the order of determinant is same. If the order is different, then for their multiplication, first of all, they should be expressed in the same order. Okay, then only they can be multiplied. Okay, so next thing, symmetric and skew symmetric determinant. So let us look out at this. Symmetric and skew symmetric determinant. So symmetric determinant. So a determinant is called symmetric determinant if for its every element, for its every element, aij is equals to aji, meaning ahg mean abc. So h g f, these both should be same. So that is symmetric determinant. Means aij is equals to aji. Next is skew symmetric determinant. So a determinant is called skew symmetric determinant for its every element aij is equals to minus aji belongs to ij. Let's look at one example. 0, 3, minus 1. So minus 3, 0, 5, 1. This becomes as 5. This 0 means 0, 0, 0. 3 minus 3 minus 1, 1. 5 minus 5. Sign should be changed. So it means every diagonal element of a skew symmetric element determinant is always 0. And the value of a skew symmetric determinant of even order is always a perfect square, and that of odd order is always 0. Okay, these 2 points you need to remember. First is every diagonal element of a skew symmetric determinant is always 0, and the second is the value of a skew symmetric determinant of an even order is always perfect square, and that of odd order is always 0. Okay, so first copy both the skew and the symmetric and the skew symmetric determinants. Okay, Okay, so next, applications of determinant. Applications of determinants. Okay, so first is Cramer's rule. So consider three linear simultaneous equations in x, y, and z. Means a1x plus b1y plus c1z is equals to d1. a2x plus b2y plus c2z is equals to a3x plus b3y plus c3z is equals to d3. That is the third. Correct? So now if determinant delta a1, b1, c1, a2, b2, c2, a3, b3, c3, delta 1 is d1, b1, c1, d2, b2, c2, d3, d3, c3, and delta 2 is a1, d1, c1, a2, d2, c2, a3, d3, c3. Delta 3 is a1, a2, a3, b1, b2, b3, and d1, d2, d3. So using all these equations means for the Cramer's rule of determinant, we get x by delta 1 is equals to y by delta 2 is equals to z by delta 3. That is x is equals to delta 1 by delta y is equals to delta 2 by delta, and z is equals to delta 3 by delta again. Correct? So here we're gonna take some cases. So case 1, if delta is not equals to 0, then delta 1 by delta y is equals to delta 2 by delta 3 by delta. So the system is consistent and has unique solutions. Next, case 2, if delta is equals to 0. So here, if at least delta 1, delta 2, delta 3 is not 0, then system of inconsistent system of equation is inconsistent. That is no solution. And if d1 is equals to d2 is equals to d3 is equals to 0, or delta 1, delta 2, delta 3 are all 0, then the system of equations has infinitely many solutions. Okay, so and write all these slides. And copy this. Next, this slide. We're gonna take two examples based on this grammar tool. Okay, then we're gonna wind up the session here, and from the next lecture we're gonna start with the solved examples for this unit. Okay, because the theory part is over. Okay, concepts are all just same. This grammar tool is very important. Okay, all these three equations you must remember for the what is equation for the no solution for infinitely solution. Okay, or equations are consistent means for the unique solution. Okay, so I think you should make a table for this and you should remember. Okay, mainly they ask question from this grammar rule only. Okay, yeah, so let us look at one problem first. Find find values of k so that following system of equations has non-trivial solution, that is x plus ky plus 3z is equals to 0, kx plus 2y plus 2z is equals to 0, then 2x plus 3y plus 4z is equals to 0. So solving here, delta is equals to 0, that means 1 k 3 k 2 2 2 3 4 is equals to 0. So 8k plus 9 plus 4k minus 12 minus 4k square minus 6 is equals to 0. So that becomes 4k square minus 13k plus 10 is equals to 0. So that means k is equals to 2 or 5 by 4. So if k is equals to 2 or 5 by 4, then the system of the equations has non-trivial solution. Has trivial solution. Okay. So you need to copy this problem. Okay. So now one more problem. The system of equations x plus y plus z is equals to 2, 2x plus y minus z is equals to 3, 3x plus 2y plus kz is equals to 4 has unique solution if k is equals to 0, k is not equals to 0, k is lying between minus 1 to 1, or k is lying between minus 2 to 2. So if you go for 1 2 3 1 1 2 1 minus 1 and k, that is not equals to 0, means k is not equals to 0. So for the unique solution, k is not equals to 0. Okay, so you can copy this also. Okay, okay, so with this we are going to wind up the session here. Okay, so thank you guys, we'll see you in the next lecture.